Example 3. Quadratic functions. fx equals ax squared. Find the derivative of fx equals ax squared from first principles. For example, y might be 3x squared or 10x squared. How do you find the derivative from first principles? Well, we use the same approach as before. Instead of y, we substitute it with y plus delta y. And in place of x, we put in x plus delta x. So y plus delta y is a into bracket x plus delta x to be squared. Squaring x plus delta x, we get x plus delta x times x plus delta x. Multiplying across, we get x by x is x squared, x by delta x is x delta x by delta x is x delta x, and delta x by delta x is delta x squared. So bringing these terms together of x delta x and x delta x, we get x squared plus 2x delta x plus delta x to be squared, multiplied by a equals y plus delta y. So multiplying in now, we get y plus delta y is ax squared plus 2ax delta x plus a delta x to be squared. So that's our y plus delta y, and we want to subtract y from that. So y plus delta y minus y, this equation minus the first equation, we get ax squared plus 2ax delta x plus a delta x squared minus the ax squared. So now we can eliminate some of the terms. The y and the minus y, the ax squared and the minus ax squared, leaving us with delta y is 2ax delta x plus a delta x squared. We're interested in delta y over delta x, so delta y over delta x is 2ax delta x over delta x plus a delta x squared over delta x. So we can rewrite that expression now and again perform eliminations. The dx delta x cancels with the delta x, and the delta x squared divided by delta x becomes delta x. So delta y over delta x is 2ax plus a delta x. And as delta x gets very small, the limit of that as it goes towards 0, delta y over delta x is called dy dx. And this being so small becomes 0 in effect when multiplied by a. It's still virtually 0, so we say the limit is dy dx is 2ax. So if we now look at the graph of y equals ax squared, we can see here's the quadratic form of it. Here's our xy and our x plus delta x, y plus delta y. And we can find the ratio now of this delta y over delta x. And from first principles, we know that if y is equal to fx is ax squared, dy dx is 2ax. So the slope is 2ax. In this case, the slope is changing because depending on the x value, you get a different answer for the slope. We also see that this particular slope turns once. It's a quadratic, it will turn once. There's an example of a different value of the slope as we move from one point to another. There's our original and moving to another, and we can see that as we change our xy from here to here, the slope changes as we move. So the slope is changing, and the function here will turn it as one minimum point or one turning point.